So execute the program what I given in the morning. Searching of anybody done? Anybody finished writing program? Searching of an element in an array. Yeah, doing. Okay, those who are done, you can showcase. So before that, I'll give one more program demo. Okay, so you just take a snapshot of that particular program as well. Okay, so then you can do both the programs together. Okay, so let me share my screen. So morning we have done the searching of element in an array, correct? Okay, so that was the program what we have done. So today what I'll do, I'll take up the sorting. Okay, sorting operation. Sorting. Okay, sorting. So that means what is the thing? The logic is this: if you have say for example n elements in an array, external, say maybe count may be present in 8,000 memory locations. So this is the count, and after that you have 10 values. Okay, so 10 values are there in the external memory. Okay, so 10 bytes. So now what we have to do? So this may be unsorted array. So we have to sort this particular array. Okay, so this n number of values we have to sort. So in ascending or descending way. So now how to do that particular task? That is the thing. So now how can we execute that particular task using a microcontroller? So that we will address in this particular session. Sorting of n number of element. Okay, n elements. Okay, elements present in external memory. Okay, so external memory. So that is the objective. So that n number of values are present in the external memory. Okay, so now for this, what I'll do, so I'll take the first number. See, I'll use something called, you may be knowing the bubble sort technique. Okay, so can anybody tell in short what is bubble sort? So can anybody tell me what is bubble sort? Just unmute yourself and tell me what is bubble sort. Anybody in the class? Anybody knows what is bubble sort? Tell in normal statements what exactly they do in bubble sort. Any idea? I mean, we may be knowing first year and all, you have done bubble sort program using C program, right? So what logic they will follow in bubble sort? Amrita, can you come online and tell me what is bubble sort? Amrita? Amrita, what is bubble sort?
Sir?
What is bubble sort?
Sir, I don't have idea.
Okay, you don't have any idea about bubble sorting? Sorting, right? Okay, Varshita is telling something, swapping. Varshita, can you come online? Could you please tell us what is this bubble sort? What is swapping? What you swap?
Sir, I remember we generally swap the elements, the alternate ones.
Okay. For what you remember? Okay, you swap elements. How you swap? On what logic you will swap? On what logic you will swap the values?
Sir, we see the order.
Okay.
On the arrangement, and we will sort.
Say for example 04, okay, 01, okay, 15, Okay, 2 0 and 0 3 is there. Okay, so this may be the elements. Then how you swap? Yes. Okay, Ryan is telling the correct answer. Compare the two values. Okay, and if the first number is greater than the second number, then swap. Correct. Okay. So if the first number is greater than the second number, then swap. So correct. Ryan answer is correct. So now in this particular case, if your input array, okay, so input array is this, okay, then what happens? So now in the first iteration, what happens? Since it compares these two values, 0, 4 and 0, 1, and since the first number is greater than the second number, it swaps. Okay, got it? Now in the next, in this iteration, this is the outcome, and remaining will be as it is. Okay. Then what happens? The pointer will move to the next two elements. Then okay, so it moved to the next two elements. So that is 0, 4 and 15. Yeah, Rupam is telling each and every element in is compared, and then the largest number is kept at the end, and rest are swapped accordingly, like ascending or descending order. Perfect. Okay. Normally, what 1 point is mentioning in this statement, the largest value will move to the end of an array. Okay. So that is what is mentioning. Yes, exactly that happens. Now you see the pointer will move to the next two elements. Now it is pointing to 0, 4 and 15. Now what happens in this particular case? Since the first number is smaller, there is no swap here. Okay, so the number will remain as it is. Okay, so this is what happens. No change, correct. Then the pointer will move to the next two elements. Okay, so 0, 4, 0, 4. Now here you see 15 and 20, no change. Okay. Then the pointer will move to the next two elements. So 0, 1, 0, 4, okay, 15. Now here you see 20 and 0, 3. 20 is greater than 3. Then in this particular case, what happens? 0, 3 will come here and 20 will move to the next point. You see? Okay. So this is what happens in the first, loop. In the first loop, if the input array is 0, 4, 0, 1, 15, 20 and 0, 3, after the first loop, okay, so this is the status of your memory. So that means 0, 1, 0, 4, 15, 0, 3 and 20. So what happens in this particular case? In this particular case, the largest element will move to the nth memory location. Okay, the last, it will sit in last memory location. That one thing happens. But they'll not, still this array is not sorted. Okay, still the array is not sorted. So this is basically one loop. They have executed one loop. This kind of loop, they will run it n minus I times. Okay, n minus I times. Say for example, again they will do the same process. Okay, so 0, 1. Okay, so now in this particular case, they will exclude this particular 20 and they will deal only with this particular 4 element. Yes. Yes. So they will deal with only this 4 element. After this, what happens? 0, 1. 0, 4, 15, 0, 3. Then pointer will move to the next two element. Okay, 0, 1, 0, 4, 15, 0, 3. Okay, then this 20 will be as it is. Okay, so there will not be change. It will be intact. Now the pointer will go to the next two elements, 0, 1, 0, 4. Okay, here you see there is a first element is larger. So 3 will come here and 15 will go to the next element and 20 will not be changed. So this is what happens in the second loop. Okay, second loop. Now in this particular case, the second largest number is moved to the the position, n minus 1 position. Okay. So next what happens? So this will keep these 15 and 20 as it is. Okay. And then it will deal with the remaining elements in array. Okay, in the rearranged. So now what happens? These 0, 1 and 4 will be compared. 0, 1, 4 and 0, 3, and there is no change. And then it will compare 4 and 0, 3, 0, 1, 0, 3. Now there is a change. 0, 4, and this element will be as it is. You understood? So now you see here, this is what happens in the third loop. Okay, third loop. Then what happens? The third largest element is moved to the n minus 2th position. Okay. So then what happens? It just freezes all the elements. Okay, it freezes all the elements and it just compares the remaining set. So 0, 4, 0, 1, there will not be any change. Okay, there will not be any change. 0, 3. Okay, so this is what happens in the last last iteration. Okay, so last iteration 0, 1, 0, 3, 0, 4, 15 and 20. Okay, so this is what happens in the first loop, second loop, and third loop, fourth loop. Okay, so in fourth loop we got the sorted array. We got the sorted array. Okay, so we got the sorted array. Now if you can see here, so if you have n number of element, okay, n minus 1 times the outer loop. Okay, outer loop. So that means in this particular case 5 minus 1, 4 loops. Okay, 4 outer loop you have to execute. Okay, and you have to execute n minus I inner loops. Okay, inner loop variable. I is basically the index of the outer loop. So this is basically index of the outer loop. Okay, so this is the index of the outer loop. Yeah. But this is not the most efficient. You have binary sort. You have different sorting mechanisms are there. Rupam, we are trying to understand how this kind of algorithm we can implement using microcontrollers. So you see, this is the logic. The logic is we understood now. This bubble sort logic, and let us implement this particular logic in a microcontroller program. That is what we are trying to do, sorting. So we see, that's what I said. You can come up with any logic. So now the thing is, ultimately you should be in a position to particular logic in microcontroller. Okay, so that's why try to spend your time in assembly programming. You'll definitely become a good programmer. That's why I said so, because that kind of tricks you have to use in the assembly programming. Okay, so I'm not just comparing which algorithm is better, but the only thing what I'm trying to convey, the sorting you can execute using bubble sort. There are many other sorting mechanisms are there, but I'm not going that. Only one sorting algorithm I'm giving logic, and I'll try to implement that particular program. Okay, will that be fine? So any clarity in the logic? So this is even if you search anywhere in the Google, you will find this algorithm, how this bubble sort works. The most important thing here is basically how you implement this particular program in microcontroller, correct? How you implement this particular microcontroller programming is very important. You see, now so your unsorted array is basically present here, right? Okay, so whatever. Okay, so initially what is the state of your array? 0, 4, 0, 1, okay, 15, okay, 15, okay, 20, and 0, 3. Okay, so this is the state, and what is your count value? Count value is not 0, it is just 0, 5, correct? 0, 5. This is the count value. Now it is very clear. Take the count value from the external memory, put it in some register like R0. Okay, keep your count value in the R0 register. Okay, and two loops you require, right? There are 2 loops are there. So copy the same value to R1 also, so that so we'll use one variable for the inner loop and other variable for the outer loop. Okay, outer loop. So that is what we will do, and then we will point to the external memory, first element, and we'll point to the second element in the external memory. We take both the elements to the microcontroller. Okay, both the elements to the microcontroller. Maybe it may come to maybe accumulator and R2. Okay, so 2 numbers will come to accumulator and R2, and do the comparison, and then okay, and then if at all, if the first number is greater, and exchange. Okay, exchange. Okay, exchange. So just exchange the value, and then immediately that exchanged value, okay, if you're exchanging immediately, okay, write back to the external memory. Whatever the exchange value is there, just write that values to the external memory, and these two locations, first and second memory location, write that exchanged value. If it is not exchanged, okay, then also you just write the updated value. Okay, then what you do, you just earlier your DPTR may be pointing to this particular memory, and then move your pointer to the next memory location. Okay, so move your pointer to the next memory location. Okay, now it is pointing the second memory location. So now from here you take two elements and bring to A and R2 register, and if at all first number is greater, exchange, and exchange value write back to the external memory. Okay, so like this continue for n number of times. Okay, n number of times in the first loop, then your largest element will move to the nth position. Here the largest number should come, so 20 should come here. Okay, so then again after first loop, then again come back to the initial position. So that is come back to this 80001 position, and again do the process till say up to n minus ith value. Then after say after executing both inner and outer loop, when it comes out, then you'll be having the sorted array. Okay, sorted array in the same memory location. In the same memory location, wherever you have given the input array, there the sorted array will be present. Okay, so you understood how I am trying to achieve using the microcontroller. Any questions on this? Bubble sorting of an array which is present in external memory, and how, where I am keeping the input array. Okay, how I am taking that particular array element, how I am what logic I am using inside a microcontroller, and how the output will come. So these are the things what you have to understand using in this particular logic. Any questions? Please do ask. Yeah, fine. Anybody have any questions? You can ask. Bubble sort. Anyway, you know the algorithm, but the only thing what you have to understand here is how we are connecting to the microcontroller program. Okay, so let me now directly go to the IDE. Okay, so this is microcontroller IDE. You know. Okay, so morning we have executed sorting algorithm. So now we'll try to implement the next program. So this is basically sorting, right? Sorting program. Okay, so sorting. Okay, so let me showcase the memory. So what I am trying to do, I'll move to 8000 memory location. In 8000 memory location, I'll keep first value will always be the count value, 05 numbers. So what is my input numbers? Input numbers are, let me take this example only so that 0401, okay, 0401, okay, 1520, 1520, and 03, correct? 06. So this is the input number. Now ultimately what I want, 01, 03, 04, 15, 20. So this is my expectation. So hope you are clear. This 05 is basically the count. This 05 is basically the count. Rest of the elements are basically the array elements. Okay. So now, so very simple things. Okay, you take you just just point your DPTR to that particular memory address, that is 800 the memory location. Just point to that particular data is present there. Take that particular data. Use movex command to take that particular data to your microcontroller. Okay, at DPTR. So 8000 memory location, whatever content is there, that is 05 will come to your A register. So now what is my next thing? So according to my logic, I need to keep that particular value in R0 and R1. Okay, so I know R1 comma A. Okay, move R0 also. Okay, R0 comma A, R1 comma A. So what is this? This is basically the count value. Okay, count value, and this is also count value. So I'll be using one value for inner loop. Okay, I'll be using this particular for inner loop, this count value for inner loop, and the R1 register content for the outer loop. Okay, so this is my plan. So the variables came. Then what I have to do? Now I have to increment. Okay, so increment DPT. Okay, so increment DPTR. Then I came to 8001th memory location now. Okay, so then move X A comma at DPTR. What happens here? Your first number comes. Okay, so first number comes. Okay, first number in an array is fetched to the microcontroller. Move X A comma at DPTR. Then I need to take the number also. So for that, what I'll do, I'll just increment DPTR. So it goes to 8002th memory location. So then again I'll use move X A comma at DPTR. Here what happened? The second number came. And that got stored in the accumulator. But the problem is previously the first number was present in accumulator is got overlapped. So for that, what we have to do, we have to keep a backup of that particular first number. So backup, I'll keep it in R2. Okay, in R2, I just kept the backup of the first number. Okay, backup of the first number. So now this is done. Now first number is present in R2 and the second number is present in accumulator now. Okay, accumulator. Now here I need to compare. Okay, so I need to compare two registers. Okay, I need to compare two registers. What to compare? One instruction is there. Compare and jump. No, I have to use I have to use subtract only. Subtract. Okay, so A comma R2. Okay, A comma R2. So just clear. See, in any case, if any carry bit is there, so that should erase, so that it gives absolutely the first number minus second number minus first number. Now here we have to think at this particular point. So now what happens in this particular case? In this particular case, A is equal to A minus R2. So what is present in A? In A, the second number is coming. The second number is basically 01. What is first number? First number is basically 04. 04 is coming. So in this particular operation, what is carry bit? Carry bit will become 1. Okay, carry will become 1. Carry or borrow, both are same in microcontroller. Carry or borrow is become 1 because first number is greater, second number is first number is lesser, second number is greater. So that is why what happens? The carry bit will become 1. Okay, so in this particular case, if carry is there, then whether I have to swap or not, that is the question what we have to ask. Okay, so what I have to do? So jump on no carry. Okay, so jump on no carry to skip. So what I have to skip? That what I have to skip. So jump on no carry. If you don't have a carry, so in this particular case I had to exchange, right? Okay, so I got a carry. Okay, so then it has to exchange. There is one instruction is there in microcontroller. You can swap two register content using XCH instruction. XCH instruction basically if you pass two register like A and R2, the A content will move to R2 and R2 content will come to A register. So this exchange operation will take place. Okay, Now this is the skip. Skip means that exchange operation you are not doing. Okay, exchange operation you are not doing. Okay, so now here one more thing what we have to understand here is, after subtract operation, the what is that, the first what is that, the second element whatever you have taken. Okay, so that will modify. So that's why what we have to do, we have to keep a backup of that particular element also. So what is this? This is basically the backup of the second number. Okay, second number. Then what I'll do, uh, before now exchange operation, I'll just move accumulator to R3. Okay, accumulator to R3. Okay, the second number I am just moving to A. Okay, second number, and the first number is anyway present in the R2, so that will get interchanged. Okay, so that will get interchanged. So along with that, what it has to do, I need to write this contents to the external memory, correct? Okay, I need to write this content to the external memory. So now what is that writing operation? So move x, okay, move x at dptr. So this is a reverse operation. Okay, so we are trying to write the data back to the external memory, correct? Okay, so in this particular case, what happens? Move x a comma at dptr. What is present in the a? Okay, so let me take here after exchange operation. Okay, so a content is moved to dptr. So now here decrement dptr. Okay, so decrement dptr. So decrement dptr is not there. dpl will see. So decrement dpl, that means the lower byte of the dptr will be decremented by 1. Okay, decremented by 1, because here it is pointing to 800 tooth memory location. So there the first number went. Now what I have to do, I have to decrement, I have to make it 800 1. Then I have to move the second number. Okay, so move x. Okay, move x at dptr comma a. So same a I should not move. What I have to move? Okay, so I have to move the R2 content. Okay, I have to move the R2 content. So that I need to copy that particular R2 content to accumulator before passing that to the external memory. Now, so this code, what this code does, this code takes two numbers from the external memory. It compares those two numbers. Okay, it compares those two numbers, and then it exchange it. The exchanged value will be returned back to the external memory. It will be returned back to the external memory. Okay, so then otherwise, if there is no carry, okay, if there is no carry, you no need to modify the external memory content. Okay, it has to be as it is. Okay, then what you have to do, you just have to decrement, decrement and jump on no zero or the inner count. So I'll use inner count as R1. Okay, to inner loop, because bubble sort has two loops. One is pushing, every time it pushes the largest element to the rare points. Okay, so now you can see here inner loop. So now after executing this particular code, what it should do, it should push the largest element to the last position. Okay, so that should at least happen. And also this program can be used to find out the largest element in an array, correct? That can also be, the same program you can use to find the largest element in a given array. Okay, so you understood this particular program swapping. Shall we test this one? Shall we test this particular program? Then we'll implement the outer loop. Yeah, so now let me run this one. Okay, mostly there should not be any problem. Okay, so I'll just end this program and I'll go to the execution mode. I'll just give this as sorting. Okay, as a name is sorting, basically bubble sort. So I just came to the run mode. Okay, run mode, and external memory data is already there. So no need to worry. So now let me check. So clear carry is only for the safer side. Clear carry is executed, and then move DPTR. DPTR is loaded with 8000, and accumulator 05 came. R0 copied with 05 and R1 copied with 05. Okay. Now the DPTR is incremented by 1. Okay. And then the value present in the external memory, that is 04, is taken to accumulator, and then the DPTR is again incremented and it become 8002, and I taken the second number. Okay, the second number I have taken. You can see the first number is present in R2 now. It's now I have taken the backup in R2, and then in R3 I am taking the second number as a backup. Now you see, second number is coming to R3 and the first number is sitting in R2 register. Okay, R2 register. So that is done. So let me go further. Now here, subtract operation A minus R2. A minus R2. R2 is basically what? 0, 4, and A register is basically 1. 1 minus 4, it will definitely, you can see here the carry bit is 0. Now when you execute this particular thing, now here you have to observe. So this carry bit is 0 now. So after executing this particular instruction, let us see. Can you see there? The carry bit is become 1 now. Okay. So carry bit become 1. Now in this particular jump on no carry to skip. Okay. So now what it has to do? It has to, jump on no carry. Yeah, it has to exchange. It has to exchange. Let us see how it exchanges. So because the accumulator content, everything is erased. So R3 content I have taken to accumulator, and anyway 1 is present in accumulator and 4 is present in R2. Then run this exchange operation. Can you see there now? 4 came to accumulator and 1 went to R2 register. Okay. Now put this particular 4 in the current memory location. Now you observe here. In this particular, now the DPTR is pointing to 8002th memory location. Now this is the one which is present there. Okay. Now in this particular position, that 04 will come after executing this instruction. Can you see there? The 04 came to that particular memory location, and then what? You see, I need to go back. I need to bring my pointer 1 less. Okay, so that's why I'm using DPL. So when I run this particular instruction, okay, now can you see here the pointer is decremented by 1. It is pointing to 8001 now. Now when I'm just taking whatever the first number which is present in R2, I'm just taking to the accumulator, and that number I am writing back to external memory. Okay, now can you see here the 4 1 become 04. Okay, 4 1 become 04. Okay, so then after that you are decrementing R1. Okay, now it become 4 and you just went back. Now again what you need to do? So now you have to increment the pointer. Okay, you need to increment the pointer to the next 2 memory location. Now what happens in this particular case? 4 and 15 will be taken to your microcontroller, and if necessary the exchange operation will happen. Okay, operation will take place in this particular loop. Okay, you understood? So in this particular case, there will not be any change. Okay, so because 15 is larger, 4 is lesser, so nothing will happen. So now let us validate. So that only the thing is, after coming here, can you see here completely that entire change that exchange operation got skipped. Got skipped. Now what I have to do? I have to decrement. Okay, I have to decrement the what is that? have to decrement, now your memory is pointing to 8003, 8003, 8001, 8002, 8003. Okay, so now here one thing should happen. So that is, it should decrement DPL because it has to come back to 800. It has to come back to 8002. Okay, 8002. So that it will take no. Yeah, no. So first 1 2 element is taken, then 2 3 element is taken, then 3 4 element should take. Now it is fine then. It is fine now. Okay, now incremented, but the thing is again it will increment the value by 1. So that means one decrement DPL should be the common. Okay, should be there here. Okay, so that means so it has to execute this. So decrement DPL. Okay, so DPL, and then so here this should not jump to after coming here, it should not jump to what is that skip decrement DPL. Okay, so that in I have to skip. Okay, it should not run that particular code. So now this is fine. So only that particular decrement DPL it will escape and it will come in the earlier case. If no carry is there, okay, if it comes here from this particular point to here, then decrement DPL will take place, and anyway it will go to the DPR and 8002 and increment DPL here, it will become 8003. 3/4 element it will take and it will work in the program. Okay. Let me reset the program and let me come back, execute from the beginning. And also this clear carry should be there inside the loop, because you are executing this subtract operation every time. So that means you know that carry should set. Otherwise, always subtract operation in microcontroller is basically this. Okay, what is this? Subtract operation is equal to, say for example, if you give sub a comma b, then it is always a is equal to a minus b minus carry bit, carry or borrow bit. So borrow bit will also be considered in the operation. So to just avoid that particular carry bit in our operation, you just make that carry bit as c. Okay, so there will not be any impact of carry bit in our subtract operation in the comparison operation. Okay, so this works for the inner loop, I think. So inner loop, this is fine. So inner loop, how many times it has to execute? Inner loop, it has to execute not 5 times, it has to execute 4 times, correct? It has to execute 4 times. So now what we'll do? So immediately we will decrement R1. So the count value will decrement by decrement R1. So now R0 and R1 will decrement by 1. Count value is always the comparison operation. You have to do it. If 5 elements are there, 4 times only you have to do. No? Okay, so in that sense, you just have to have this particular value. Okay. So now the next thing is, so this is fine. Okay. So this is the inner loop. So in this particular loop, let us take the same array. So 0 4 0 1. So I'll run it continuously. Okay. So I'll just animate this particular program. I'll just come here and I'll just try to animate. I'll just try to observe. Okay. So only in 20 and 3 should change. Yeah. Can you understand here? Now you see here, this is what happened. Okay. So this particular loop we have achieved. So the first iteration. So after first iteration, 0, 4, 0, 1, 15, 0, 3 and 20. Okay, so those elements came to your external memory. Okay, those elements came to your external memory. Okay. So any questions on this program? Yeah. Because I'll attach the outer loop. You should not feel any confusion. Okay, so that's why if you have any confusion, please do ask. Bubble sort, the first inner loop I executed. Like this, I have to execute n minus I times, or even if you execute n times, performance is the problem, but output you will get it. Only the thing is unnecessary iterations it will run. Any questions on this? All of you? Any questions on this sorting program? Okay, now I'll just implement the outer loop. See, what is that outer loop? What we have to do? So this is inner loop, 4 times we have to execute. So like this, okay. So we have to execute this instruction, okay, n minus I times. Now what I'll do, I'll just execute this particular instruction. Okay, so n times only. That means 4 times only. Decrement and jump on no zero. Okay, R naught. Okay, R naught is the outer loop. So decrement R naught and go to outer loop. Okay, so this is basically the outer loop. So now here I am coming back to this particular point. Okay, so this is outer loop. Now inside this particular outer loop, what are the things it should happen? See, when you come back to the outer loop, your memory, data memory should point to the first memory location, correct? Your data memory should point to the first memory location, and it has to take the count value as well. Okay, so it has to count that R1 value, the inner loop. What is that? Not so this is outer loop, no? Outer loop, and this is inner loop. Okay, so the inner loop variable should reset, one thing. Okay, and outer loop outer loop value should be decremented. So anyway, it will happen. Now, whenever you go to the outer loop, so entire thing it has to replace. So that means it has to take the inner loop count value. It has to reset the inner loop count value. Yeah, please answer. So you can somehow, because I need to finish it. Okay. Okay. So now you see here. Now in this particular case, what happens? The R1 will always reset whenever it comes to the outer loop, correct? That means again DPTR is also becoming 800. That means it is coming back to the starting position. You understood what are the things happening at this particular point? So the data pointer is coming to the starting point, and the count value, the inner loop count value, it is resetting. Okay, and whenever it goes to the inner loop, the new value will be taken. Like 4 will go to the inner loop, and it will decrement 4, 3, 2, 1, and it will come out. So these things happens in the outer loop. Okay, in the outer loop. So you understood this particular part? So you are decrementing that R naught. R naught anyway I am not touching. It is outside the outer loop. So whatever you have taken, say for example, if it is 4, 4 is there. 4 times it will execute and it terminates the outer loop and it will come back here. After this particular point, you no need to worry anything. Okay, so your external memory is already sorted. Okay, external memory is already sorted. So this is what happens here. So let me quickly run this program, whether everything is working properly or not. So let me take the same array. 0401. Okay, so same example I'll take 0401 15 15. Okay, 2003. Okay, 15 2003. So this is the data what I've taken. So now after running this particular program, what you should expect? So this array should sort. So there should be all the elements should sort now. So let me go to the run mode. So I just came to the run mode and I'll try to animate this one. Okay. So let's see whether okay, I'm just running the program. It went inside the first loop, and 04 and 01 got interchanged, and 4 and 15, nothing will happen. Only 20 and 03 should change. It got changed. Okay, and again outer loop variable is got changed. In this particular case, 15 and 03 should change in this particular loop. Okay, 15 and 03 should change. 15 and 03 got changed, and then nothing should change here. And outer loop reset. In this particular iteration, 04 and 03 will change. Yeah, 04 and 03 got changed. And then, okay, again it is going to the next iteration. Okay, so in this particular iteration, there change. So it simply runs this particular program for 4 times. Okay, and it will come and it will end the program. Okay, it will end the program. So now if you see the array, it is sorted. It is sorted in the external memory. Okay, so this is what the bubble sort program is. Okay, so bubble sort program in the assembly code. Okay, so assembly level programming. Okay, so this is the sorting. Okay, sorting an array. Okay, in external memory. Okay, X memory. Okay, so what technique you are using? Using bubble sort. Okay, so this much is the program. So any questions on the program? Please do ask. I'm just open that particular program, and each and everything has some meaning. Okay, if you have any questions. Okay, so let me know. I'll quickly answer. Yeah, please take a snapshot of this particular program as well. Yeah, please take a snapshot of this particular program. Uh, I just wanted to. Yeah, you please take a snapshot of this particular program. Any questions? Any questions from anybody? So two programs are ready for you now. One is searching program, what we have done in the morning, and this is basically sorting program in assembly level. Okay. Any questions? Any questions? So please execute these two program, at least searching program in your machine, and please share your screen, and simultaneously I'll give these two things are separate. Searching and sorting are two experiment. After searching a program, you show me. I'll just give the marks. Whoever is ready, you can tell, and after showing that, you can take a leave. Yeah. So Gnanadas, I'll just give the control to you. You can showcase. Okay, so who is ready? Gnanadas, right? So Gnanadas, I am just stopping my screen. Okay, so I'll just give the control to you. Yes, Gnanadas, given control to you. You can showcase. So attendance will be given for those who have showcased the program. Yeah, go to your memory Gnanadas. Yeah, now give data and run. That's I'll just see that. Now first element should be, count value, give some good number. So 7f in 7fff is there na. Before that 7fff, that is the value of search element. No, Gnanadas. In 7fff memory, you just have to give your search element. What you need to search in the array. Here, whatever you are trying to keep in the first place, that is basically count value. 7f has, it is too much of big value, right? Lot of value you need to. That memory location, give some, 04. That is. So 4 element, only 3 element given, because 4 is the count. 03, fine. Now, what you need to search in this array, that should be there in 7fff. So before 8001, that the previous row last element is the address 7fff, last element. Yeah, in that row 8000 row is there na. So before that last element is there na. So that, not that one, 7ff4, that is, yeah, last element. Yeah, that is 7fff memory. Yeah, you can keep the search element. Okay, so what is one, you can give, yeah, any value you can give. In a 7ff you have to give some value na. So 03, 04, 02, 06 is there, you can give 03. So now 1, the frequency of repetition of that particular element is 1 time. So now after 6, 1 should come. That is what is expected. After this 6 values there, now after that 1 should come after execution of this program. Run it. Animation is okay. Yeah, perfect. So can you change 05 to 03 and run it again? That 05 is there. Change it. Yeah, 03. Make it 03. Yeah, run it again. Fine. Only one. I just want count value to come as 2. That's it. Run it again. No. After running 03 repeating 2 times. Correct? 03 coming 2 times, no?
Yes, sir.
So now it is showing 1 only.
After 6, 1.
After 6, 1 is coming. Na? So your search element is 3. The 3 is present 2 times in your array, correct?
Yes, sir.
So that means value 2 should come. Na? So the increment R2, 0 1th memory location, 0 1th memory location, you have a search element. Search element you are comparing with accumulator content. 0303 should result in compare and jump on not equal. If it is equal, it will increment. Increment R2 value is 0 0. Okay, so 0 0 will become 1. Then after that, and it goes to second iteration. It should be 2. Run once again, Gnanadas, because program is looks fine. Okay. Yeah. Now, what you do, you step by step you run Gnanadas. Okay. So step by step. That foot mark is there, na? Just try to run that one. Okay. Yeah, I'll just debug that program. Okay. File does not contain any part running program. Yeah, close it. Click on that foot mark. File does not contain any part of running program. What does it mean? Unable to comply. Click on the foot mark which is next to that simulator button. Yeah. Yeah, actually, this may be the click. Where is that
clicking,
pointer?
sir.
Yeah, pointer is yeah, getting a
No, sir, I'm clicking on
04.
it.
That green color pointer should come. That is not coming. Okay. Anyway, you can see now. You can yeah. Okay, let us see the memory. Your count value are trying to store it in R2. R202. Yeah, R202. It becomes 02 na. After 02, what is happening? After 02, you should get, yeah. Run it. Keep pressing that step button. Yeah. Now see in the memory, because R2 is R2. Yeah, correct. Done. Okay, this is correct.
Yes, sir. No.
Earlier
But
one was coming. I don't know why. Yeah. Now this is fine, right? Close
yes, sir.
Gnanadas. If anybody is ready, you can give a them. Yeah, give control to Ryan. Huh? He is asking. Give control to Ryan. Good work, Gnanadas. You got control. You can show the program. If just all of you, just open your screen and just run the program and show the output. I'll just see that. If any issues are there, even then you can ask me. So let us fix if any problems are there. If you have any problem in writing program or something like that, okay. So let me know. I'll work in your machine. Huh?
So can you see it?
Yes, I can see your screen. You can showcase. Yeah, program is fine. Okay. So search element 07 twice is coming. Yeah. Okay. Make one element, say one more, say 07, keep it in your memory. Make one more 07.
So there's two.
Yeah, instead of 01, you just make it one more 07. I just want to see count. Yeah, any one element, you just make it 07. Run is also fine. Animation, it just click on run button and that's it. So 02 only is there. Run it.
I'm running it.
Yeah, please. Don't run step by step. There is one more option in simulator and run. You can click on that. Yeah.
Run 3.
Yes, fine. Yeah, great. I gave full marks, Ryan. Okay.
Thank you.
Give control to whoever is ready. Anyway, please put it in chat box. Ryan will give the control to you. You are writing bubble sort. Will you show the bubble sort also? I'll give marks to that also.
I haven't run it, sir. I haven't checked it.
Oh, you haven't checked it. If it is, you can show and you can get the marks. Immediately I'll allocate. Huh?
I'll do it later. I mean, I've completed.
Fine. So, Amruta, give control to Amruta. She's is ready. Huh? Give control to Amruta, right? So everybody should show your screen. This will be considered as attendance as well. Okay, so if you are done, okay, you get to showcase.
So how do you give control?
Right click on their name in your screen. Presenter, right click and make presenter one button will be there. That's it. You got? Otherwise, I'll just Amruta, right? Amruta. Yeah, I just transferred role to Amruta. Amruta, you can present now. So your search element, no. This is what you element. Yeah, can you show us? Show the memory. See, I'm don't always stuck to my programs. Whatever flow I'm using. What you do, you just use your logic and try to write the program from the basic. Try to create your program. Okay. So otherwise, you feel difficult. So 01 should not be there in the 80001 memory location because that is the count value, right? The number of elements what will have in the preceding memory location. So 02 means it will consider only 21 and 11. You understood, na, Amrita? So 02 consider only 21 and 11. Among that, only it will. 03 means it will 21, 11, 11. Only you want to, your array size is only 3. Yeah. Yeah, if you give all those values, it will not be considered because your array size is 3. Make it something like 5 or 6, something like that. your point cursor should be beginning, yeah, like 0 no, 31 11 11. So give search element as 11 in the 7ff memory location. The previous row last element is the memory location of 7f. Yeah, that's the one. Put 11 11 because two elements are repeating. No, put 11. Oh no, always your cursor should be at the beginning. Now you see change that 15 to 05 next to 800 memory location. It become, yeah, cursor should be at the beginning. Yeah, whenever you are. Yeah, now run, just run. Go to simulator and run. That's it. And come back to this memory. You'll see the result. Yeah, click on that simulator button. Go to simulation mode, and don't run step by step. I mean, go to simulator mode and then go to simulator and run. You just have to go to no, you're not at the simulation. Okay, you have to start. Your screen got disconnected. Um, Amrita, you got disconnected. I am unable to see any thing in your screen. Yeah, now I could able to see. So yeah, now it went came. Go to simulator and run. Yeah, okay. Now go to memory, which is minimized, not minimized. Huh? Okay, open. Yeah, X data. Click on that. Yeah, go to 800. Yeah, okay. So 2 is the count, right? 2 is the count. Make 20 as also as 11. Make 20 also as 11 in your array. Sorry, called me. Okay, so Amrita, yours is fine, huh? Yours is fine, no problem.
Okay.
So give control to the next person. So
Who,
give
sir?
control to Namita.
Sir, I'll do it, sir.
No, the sequence in which they are asking in the chat box like that, huh? Give control to Namita. So memory show, that's it, huh? Yeah, very good, very good. 10 is not there, 0 is the count. Yeah, fine, Namita. Just give control to Muhammad, Yusuf. You got full marks. Give control to Yusuf, huh? Those who are done the experiment, start working on that sorting, and you can take a leave from the class. Okay, so when I ask next time, you just showcase and get the marks. Okay, if you want to show that program as well today itself, you can show and get the marks. Yeah. Yeah, perfect, Mohammed. Just give control to Sayak, Mohammed. Anujit, Shreyans, Priyanshu, Pulashita, Hari, Pavan, Iqbal, you haven't got any marks in the lab, okay? Almost we are evaluating for 25 out of 25 marks. You got 0, huh? Sayak, you are showing searching operation, right?
So this one is for today's experiment.
Sorting?
Yes, sir.
Yeah, morning we have done searching. You may not be there. Yeah, okay. Showcase. Open the program. Am I audible?
Yes, sir. Yes, sir.
Yeah.
Can you see it, sir?
Yeah. Is this? This is searching program, sir.
Yes, sir. The morning one.
Okay, sir. Give control to program is fine. Okay, yeah, fine. Give control to Shoaib, huh? Give control to Shoaib. So you got full 5 marks, Saib. Shoaib, yeah. You executed. But search element, where you will keep search element, you know? Shoaib, where to keep the search element, you know?
Yes, sir. 1 minute.
Yeah, please keep search element. Where you'll keep the search element?
Here I'll give, sir. In 7.
Yeah. Perfect.
I can keep 11, sir.
You can keep 11. With cursor, be careful in the memory. Yeah. Not in the middle, it is pointing. So just click on the, yeah, now. Yeah, number of element 16 is there. Just change that to 6. Yeah, now run. Yeah, show the memory. Yeah, one time it is repeating, which is coming. Yeah, after one. Yeah, this is fine. Shoaib. So Shoaib, you can give control to Namita. What you are asking? Okay. Shoaib, you can give control to Varshita. You want the control now?
Yes, sir.
Yeah, give control to Varshita.
Okay, sir.
No, I'll give. No problem. You stop sharing. I'll give control. No problem. Varshita, I gave control to you. Varshita, will you showcase now? Got control, right? Yes, share maybe entire screen or something like that. Yeah. Fine, Varshita. You can transfer to Abraham. Give control to Abraham. You got full marks, Varshita. Give control to Abraham. So you can stop sharing and give control to Abraham.
Sir, I have stopped sharing.
Yeah, fine. So Abraham Matthews, I'm giving control to you.
Okay, sir.
Yeah, you can present now.
Sir, see.
Okay, six numbers. Yeah, put 404. Just give and run. Matthews 04. You put it in 7FFF memory location. In 7FFF memory location, instead of 11, put 04 and run. Let's see. Yeah, run now. Simply run. That's it. Yeah, open memory. One more time open it. Normally it will minimize, try to minimize. No, open virtual hardware, just click on that and open again one more time. Okay, 04, you ran, right?
Yes, sir.
So, but why that count value is 2, right? Yeah, 4. 06 element, 6 element means 5, 4, 0, 3, 2. So 4 is the search element. Some issues are there, right? You ran that program?
Sir, yes. Sir, I'll run.
Run again. Because 04 you have, that means, no, yeah, now. I think Alt tab you try to press so that you know that memory may come. Yeah, this is fine.
Okay.
This is fine. Yeah, you can give control to John. Huh?
Okay.
Yeah. So John, take control. You got control, John? Yeah, present it, John. Yeah, Ryan, there may be some setting problem. That green color, just some go to some menu bar, try to enable, huh? Rupam, you can showcase both the programs. When you come next class, now unnecessarily, you know not to wait. You tell me that you showed, and you can take a leave from the class. Aita, sir. See, in your 8000 memory location, it should not be 1 or 2. I mean, that means only 2 element it will consider. Na? That you should know. Huh? Because count value, depending upon your count value, only your program runs, right? Huh? Yeah, I mean, some greater value is fine. More than 5 is fine. So instead of the 0 to make it something 45 or something like that, John. Yeah, now run again. Yeah. That is also an indication that, show the memory once. Forty-five is there, right? Your count value should be 1, huh? In execute problem. 45 is there in your array. 52, 63, 45, 65. That is array. So have you executed this program? Run, right? So any issues are there? Shall we debug the program then? Go to your program, go to your program, go to your program. Okay. 0 move R2 to 0 A comma delete here, move search element. Okay, to R1. R1, R2, 01H key to R2. Delete your count value. So R0. Okay. Decrement R0 and jump on no to the loop. R200. Can you run step by step, John? The program is fine.
Step by step.
As no, there is one footmark button is there, na? Just keep pressing that particular button. Step run. Yeah, that one. Yeah. Yeah. Now that means you first close the simulator mode and again come back to simulator mode, then run. Huh? Again come again click on the same button and click on the step mark button. Okay, that step run. Yeah. Okay, run. Not run, step input, step, not run, step run. Yeah, 45 came, okay, then step run. Okay, again. Just, yeah, again. Okay, again. Done. Yeah, okay. Keep coming. Okay, just a second. Yeah, R2 is become 1, right? R2 came. Yeah, yes, fine. Just click on animate. Click on the simulator animate. Yeah, just come back to your memory. Yeah, fine, John, it's working. Hmm? So you can give control to Gnanadas. You want to show sorting also? Gnanadas, you want to show sorting also? So if you want to show sorting, you can show. Shall I give control to Gnanadas? You can stop sharing, John. Huh?
So he left, I think.
He left, huh? Okay. Then, so Rupam, you are saying something? Both experiment you can showcase. 5 marks for each experiment. No? So,
Sir, the first is searching, right?
yes, yes.
And second one, and the
Yes,
second
sorting.
one is bubble sort, right?
Yes, yes.
Okay, sir. Sorting and 1 minute.
So searching you already showed. You have to show at least one by one, at least showcase. Now this is your turn. That's why. Huh?
Presenter
Control.
I'm showing the
Yeah,
search.
John, shift the presenter role to Rupam. Huh? So everybody should showcase. Otherwise, even there in the meeting, attendings will not be given those who are not showing the experiment. Okay. Okay.
This is the X data. I already seen it. This is the output that's
Okay.
coming.
Uh, why your memory is three digit?
No, sir, that's the same confusion I had because every having 2-bit memory. I don't know 3-bit memory. Why am I
You
having?
have 12-bit memory location you have, correct? No. Here there is one button is there above menu bar. Decimal you just set. You set that to decimal. Click on that drop down and select X. Then it will become 8-bit. Now it is fine, right now?
Yes.
Yeah, fine. 25. Fine. You can give control to Ashwin. Huh?
Okay, sir.
I gave 4 marks to you, Rupa. Ashwin, you can showcase, I think.
Sir, I don't have the presenter role.
Okay. Yes, that's okay. Now check.
Yes, sir, now I have it. Is my screen visible?
Yes. Just showcase your external.
I have 3 experiments to show, sir. Last week's 2 experiments also are there.
So last week experiment is there?
2 and 3, sir. I was not in class that day.
Okay, so just showcase. So
Yeah, this is today's
showcase.
Today's search program, sir.
Okay. Hold on. I'll just ask if it is required. Huh? Okay.
This is addition of numbers, summation.
Okay. 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 Next program.
This is finding the largest.
Finding the largest. Okay. Fine. So fine. I think you can give control to Aniket. Huh?
Okay, sir.
So you, I think I'll experiment. So since there is a delay, there is some lex marks is there, Ashwin. Fine.
I understand, sir.
Yeah.
I have passed it to
Yes. Give control to Aniket. Aniket, you can present. Huh? I'll just see Aniket program. If it is fine, then I'll just yeah. You can give control to Ryan. Ryan want to show. I give full marks to you, Aniket. Huh? Give control to Ryan. Huh? Ryan, you can showcase the sorting also, so that if you want to claim that marks, you can get it. Yeah. Hmm. 6, 12, 15, 20, 26, 31, 55, 65. Great. Very good, Ryan. So for that experiment also, I'm giving 5 marks, but you're not sure to experiment. Okay, so just make an arrangement for that, huh? So
Okay, sir.
yeah, you can call Shaker.
So can you do that?
Yes, I'll do. Yeah. Gunashekar, check once.
Yes, sir, I got some.
Yeah. Hari, just you have not showed any program. Hari, Pavan, and Iqbal. Pulashita, Hari, Pavan.
Sir,
Okay, yeah.
sir, I did both sorting and searching of elements, sir.
Okay, you just show the sorting.
So this is sorting.
Okay, show searching.
Sir, this is searching of elements.
Just a wait.
Can I run, sir?
No. I'll see if it is this trivial program. No problem.
It's okay, sir.
Yeah, fine. You can close. So both the experiment I give full marks. Huh?
Yes, sir. Thank you.
So anybody want to showcase? I did not get any request from the chat box. So is you showed any program? So just have to take care of yourself.
Sir, sorting can be shown next class also.
Yes. I know. Just if you showcase now, no need to show in the next class. You can engage with some other work now.
Still doing it.
Yes, fine then. You can show in the next class. Okay. So shall we close today's class then?
Hello. Yes, sir.
Dawood, you are speaking?
Yeah. Yeah, sir. Actually, I texted also in the chat box. I have some software issue. I'm taking Ashwin's help. So the software was, I'll show you all the experiments.
Okay, no problem. So as you know, if it is delayed, then I have to deduct some marks. So that's why.
Yes, sir,
So
I'll
if
show you.
it is early,
Yeah.
fine. Just take care. That's it. Hari,
Yes, sir.
Hari, you are not showed any program. Hari, when you will show?
Because I not have laptop, sir.
Okay. So now, then how you do?
Class I will show, sir.
Uh-huh.
Just class.
Okay, so now the thing is, next class, other experiment we'll be doing, I can't evaluate the previous experiments, completely in 1 or 2 experiments is fine. All 5 experiments are not done. Okay, so I won't evaluate. So if marks is less, don't, so you have to accept. So you do it fast, so that I can consider. I can consider and I can evaluate. So same case for you inform Pavan also, Pularshita also. So you have not done any experiment. Okay, so it will be a problem for you only. Priyanshu also not done. Shreyans also. Okay, so yeah.
No,
So
sir, I'm working with the software, right?
yeah, please, please work and let me know.
Yeah, sir. Once it's working, I'll do it.
Yeah. Okay, next lab we'll see then. Okay. Thank you all. Bye. Okay. Shall we close? Okay. Thank you. So I'm